Data mining is a process of applying analytical techniques to a data set to find hidden structures, patterns, and relationships among variables. So in this chapter, we first provide an overview of data mining process, and the two primary data mining techniques, supervised and unsupervised data mining. We then explore three key issues that are relevant to data mining. The issues are similarity measures, predictive performance assessment, and data reduction or dimension reduction. And these are important to understand supervised and unsupervised data mining techniques. Also, we are going to talk about similarity measures, the ones that are quantifying how a group of observations are similar or dissimilar to one another and are essential to many data mining techniques. Assessment of predictive performance is a critical step for model selection in supervised data mining, and we did this before. So this is the plan for the data mining chapter. The terms artificial intelligence, machine learning, and data mining are all used interchangeably, and their definitions overlap with no clear boundaries. They describe, all of them, applications of computer software used to obtain insightful solutions that traditional data analysis techniques may not be able to achieve. What is artificial intelligence, or what is used for? It's used to describe computer systems that demonstrate human-like intelligence and cognitive abilities, like pattern recognition. Machine learning describes techniques that integrate self-learning algorithms. It's an application of artificial intelligence that allows the computer to learn automatically without human intervention or assistance. So the machine learning is kind of application of the artificial intelligence. It's designed to evaluate results and to improve performance over time. Machine learning techniques can uncover hidden patterns and relationships in data. Also, it uses self-learning algorithms to evaluate results and improve performance over time. Example about that, predict rider demand to strategically dispatch drivers for Uber. For data mining as a definition or as a term describes the process of applying a set of analytical techniques necessary for the development of machine learning and artificial intelligence. And it's recognized as a building block of machine learning and artificial intelligence. Why? Because it's uncovering hidden patterns and relationships in data and gain insights and derive relevant information to help make decisions. And they are used for data segmentation, pattern recognition, classification, and prediction. Examples: group customers into segments for customized promotions. So the data mining techniques, it has a process, or the data mining is a complex process of examining data and applying analytical techniques to gain valuable insights. And a popular approach adopted by many practitioners is based on cross-industry standards process for data mining, CRISP methodology. And there are other data techniques methodologies or data mining methodologies, but we are going in this class to focus on CRISP-DM. What is a CRISP-DM? CRISP-DM consists of 6 major phases: business understanding, data understanding, data preparation, modeling evaluation, and deployment. And we can summarize them as follows. Business understanding, it is the first phase, focuses on understanding the data mining project and its business objectives. Information about the situational context around the data mining project is gathered during this phase in order to define specific objectives. So this is the first phase. The first phase, we have to define specific objectives or goal of the business, like predict the number of units sold to a customer segment or increase the sales in a particular region. Also, it contains the project schedule and the deliverable. What are the things that we're going to deliver at the end of this project? The second phase, which is data understanding, this phase involves collecting relevant data and conducting introductory analysis to understand the data. Results from this initial analysis may lead to ideas and potential hypotheses for subsequent data mining phases. Examples about this is data visualization and conducting a descriptive and summary statistics. After that, we move to the phase 3, which is data preparation. In this phase, it includes record and variable selection, data wrangling, data management, cleansing for subsequent analysis. For example, certain data mining techniques may require subsetting and transformation of numerical and categorical data. And this is exactly what we covered in Chapter 2. After that, we have the modeling, which is phase 4. It involves the selection and execution of data mining techniques, which is the big chunk. The second, or the data preparation, takes a lot of time, but the modeling also is important because this one that you have to select and execute data mining techniques, including all of the techniques that we have covered yet and the ones that we're going to cover later, like linear and logistic regression models, and any other predictive models and prescriptive analytics techniques. Certain analysis techniques require specific formats and types of variables in the data set. For example, a traditional naive Bayes can only work with categorical variables, so we need to sit back to the data preparation phase to convert or transform data. Next phase is evaluation. So after developing data mining models, we evaluate the performance of competing models based on specific criteria in order to select the best model that meets the business objectives of the project. We then review and interpret the results in the context of the business objectives described in the first phase. And we already discussed some of the performance measures, and we're going to discuss more. Finally, the last step is the deployment. During this final phase, we develop a set of actionable recommendations based on the analysis of the results. And similar to other projects, we need a strategy for deployment, monitoring, and feedback. This is the cycle. And it's important to note that not every step of the CRISP DM is needed for all data mining applications. The data preparation phase plays a significant role in the data mining process. Basically, 80% of the time data analysts spend just for understanding and data preparation, for cleansing, transformation, preparation, and so on. Data mining algorithm can be classified into supervised and unsupervised techniques. So it depends on the way that they learn about data to make predictions or identify patterns. For developing predictive models, one needs to employ supervised data mining techniques. Unsupervised data techniques or data mining techniques are especially effective for data exploration, data or dimension reduction, and pattern recognition. The key distinction between supervised and unsupervised technique is that the supervised data mining, the target variable is identified. We know what is the target variable. We know the response. In regression models, it's common to refer to the target variable as a response variable. On the contrary, in unsupervised data mining, no target variable is identified. Some of the most common used supervised data mining models include the linear regression model and the logistic regression model. These are examples of supervised techniques. These models are used to predict the outcomes of a target variable based on several predictor variables. The mathematical model relates the outcome of the target variable to one or more predictor variables. Consequently, we use information on the predictor variables to predict the value of the response or target variable. In this, we will be discussing other machine learning algorithms used in supervised data mining. We will be discussing 3 more techniques: k-nearest neighbors, naive Bayes, and decision trees. Common applications of supervised data mining include classification and prediction models. In the classification models, the target variable is categorical. The objective of a classification model is to predict the class memberships of new cases. For instance, a marketing manager may classify a list of prospective customers as buyers and non-buyers. A financial analyst may classify a stock into one of the following 3 classes: buy, hold, and sell. In a prediction model, the target variable is numerical. Examples of prediction models include predicting the spending of a customer, the selling price of a house, or the length of a hospital stay after a medical procedure. Unlike supervised learning, unsupervised data mining requires no knowledge of the target variable. It's called unsupervised because the algorithm allows the computer to identify patterns and relationships in the data without any specific guidance from the analyst. In the field of business analytics, unsupervised learning is considered to be an important part of exploratory data analysis and descriptive analytics. It's also used prior to conducting supervised learning in order to understand the dataset, formulate questions, or summarize data. Common applications of supervised learning including dimension reduction and pattern recognition. Dimension reduction refers to the process of converting a set of high-dimensional data into data with smaller number of variables without losing much of information in the original data. Pattern recognition is the process of recognizing patterns using machine learning techniques. A pattern may be recurring sequences of behaviors of customers, frequent combinations of words in documents, recognizable features of objects, or common characteristics of things that belongs to the same group. For example, retail companies use pattern recognition techniques to group customers into different market segments in order to customize product and service offerings that are of interest to each segment. So this is everything about the introduction about data mining and supervised and unsupervised data techniques. Next, we will be covering similarity measures. Thank you.